Hello students, the question is, consider a circular disc of radius 20 centimeters with center located at the origin. A circular hole of radius 5 centimeter is cut from this disc in such a way that the edge of the hole touches the edge of the disc. The distance of center of mass of the residual or remaining disc from the origin will be option 1 2 centimeters, option 2 0.5 centimeters, option 3 1.5 centimeters and option 4 1 centimeter. So the problem is based on the topic center of mass. Now in this particular problem there is a disc. There is a disc having a radius of 20 centimeters. So this is 20 centimeters. Now from this disc a certain section is cut in a circular manner. A cavity is created. Now this particular cavity is having a radius of 5 centimeter and the edge of this cavity is touching the circumference or the edge of this circular disc, whole circular disc. And we have to find out the center of mass of the remaining disc. Remaining means after creating the cavity, what is the new center of mass? Before the creation of the cavity, the center of mass is exactly at the origin because the disc is assumed to be uniformly distributed mass. Now after the creation of cavity, we have to calculate the new center of mass. Now logically, if a cavity is created in this manner, then the center of mass is shifted in this direction, towards the leftward direction as shown in this figure. If a cavity is created here, the center of mass is somewhere here. Now we have to find out the exact location. For the sake of simplicity, we assume the edge of this cavity to be on the x-axis. Let this be on the x-axis. And the line joining the respective centers is the x-axis. Let the center of the original disc is at O and the center of the cavity be at O dash. Now to calculate the center of mass of the new or the remaining disc, we have to use this formula. X center of mass is equal to the mass of the disc without the creation of the cavity into the center of mass without the creation of cavity minus the new mass. For example, the new mass is m dash into the center of mass of the cavity, let it be x2 position upon m minus m dash. Now let us assume that the mass of cavity, mass of the section for the creation of cavity is equal to small m. Mass for the creation of cavity is small m. Now we know the formula that mass is equal to the surface mass density multiplied by the area. Now suppose the mass of the section for creation of cavity is small m, as we have written here. Now this is equal to sigma times area. Now area is nothing but pi r square, which means that pi into 5 square, because the radius of the cavity section is 5 centimeters. So that's why this is small m equals to sigma pi 5 square. This is equation number 1. Similarly, the mass of the whole disc, which is equal to m equals to sigma times 20 square, because the radius of the whole disc is 20. Now dividing these two equations, equation 2 by equation 1, so we get capital M upon small m is equal to sigma pi 20 square upon sigma pi 5 square. Now in this way capital M comes out to be, now sigma pi cancels with sigma pi, and for 20 square is basically 400 upon 5 square is 25, so this comes out to be 16. Cross multiplying this small m, we get this value as 16m. So the mass of the whole disc without creation of cavity is 16m. Now we have to put these respective values here. Now in place of this capital M, we have to put 16m, and the position of the center of mass when there is no creation of cavity. So in this case, this is 16m multiplied by 0, because the center of mass of the disk when there is no creation of cavity is at the center, minus m dash. M dash is basically the mass of this particular section, the cavity section, the mass removed for creation of the cavity. So this is equal to small m multiplied by the position of the center of mass of this cavity, which is at 15 centimeter, because this distance is 20 from center to edge, and this distance is 5 centimeters. So the remaining distance is 15. So this comes out to be 15 divided by m minus m dash. So 16m minus small m. Now in this way, this comes out to be this value comes out to be 0 minus 15m upon 15m, which is equal to minus 1. So the location of the center of mass is at minus 1 comma 0, or we can say that minus 1 centimeter away from the origin. So option 4 is correct here. Option 4 is the correct answer here. तो यहाँ एक कैविटी बेस्ड प्रॉब्लम पूछी गई है सेंटर ऑफ मास टॉपिक से. इसमें कहा गया है कि एक सर्कुलर डिस्क है 20 सेंटीमीटर की, उसका सेंटर जो है लोकेटेड है ओरिजिन पे, उसमें एक सर्कुलर होल क्रिएट किया गया है रेडियस 5 सेंटीमीटर का. इस तरह से किया गया है कि उसकी एज जो है वो टच होती है एज ऑफ द डिस्क से. हमें बताना है डिस्टेंस ऑफ द सेंटर ऑफ मास, रेसिडुअल मास या रेसिडुअल डिस्क ओरिजिन से कितनी होगी. तो जो न्यू क्रिएटेड रिमेनिंग डिस्क है उसका एक तरह से हमसे सेंटर ऑफ मास की लोकेशन पूछी गई है. तो उसके लिए जो फॉर्मूला हम यूज़ करेंगे वो यूज़ करेंगे x सेंटर ऑफ मास इक्वल्स टू मास ऑफ द होल डिस्क जबकि कैविटी क्रिएट नहीं की गई थी उस समय जो मास है, मल्टीप्लाइड बाय उस समय जो सेंटर ऑफ मास है उसकी लोकेशन, माइनस मास जो निकाला गया है कैविटी क्रिएट करने के लिए वो पर्टिकुलर मास इनटू लोकेशन ऑफ दिस कैविटी सेक्शन अपॉन मास कैपिटल M माइनस m डैश. तो ये हमें निकालना है. तो उसके लिए हम सबसे पहले जो बेसिक कंसेप्ट है यहाँ पे वो ये है कि मास बराबर होता है सरफेस मास डेंसिटी मल्टीप्लाइड बाय एरिया. ये कंसेप्ट हम यहाँ पे यूज़ करेंगे. तो अगर हम मास को स्मॉल m मानते हैं कैविटी वाले सेक्शन के क्रिएशन के लिए, कैविटी के लिए मास को स्मॉल m मानते हैं, तो बराबर हो जाएगा सिग्मा इंटू पाई इंटू 5 स्क्वायर, क्योंकि कैविटी सेक्शन की रेडियस 5 है. इसी तरह से मास ऑफ द होल डिस्क कहा जाएगा कैपिटल M बराबर सिग्मा इंटू पाई इंटू 20 स्क्वायर. दोनों इक्वेशंस को डिवाइड किया, कैपिटल M को स्मॉल m के टर्म्स में एक्सप्रेस कर दिया. स्मॉल m हमने माना है मास ऑफ द कैविटी सेक्शन क्रिएशन के लिए जो मास रिमूव किया गया वो पर्टिकुलर मास, और कैपिटल M जो है वो है होल डिस्क का मास जबकि कैविटी क्रिएट नहीं की गई थी. तो इन दोनों को हमने वैल्यूज़ को निकाला, कैपिटल M को स्मॉल m के टर्म्स में वैल्यूज़ हमने रेस्पेक्टिवली यहाँ पुट करी, और लोकेशन ऑफ द सेंटर ऑफ मास उससे हमारी आती है -1 सेंटीमीटर्स. So this is the whole explanation of this problem. Hope you understand it. Thank you.